here we go. Our last topic for our quiz is polar. So let S be the region bounded by the graph of the polar curve, as shown in the figure above. So we have the equation for the curve, and we have from 0 to square root of pi. So it must come back to the pole at square root of pi. Find the area of S. So the area of a polar curve is 1/2 integral from A to B of r squared d theta. And it comes from the area of a sector of a circle. So the area of a sector is 1/2 r squared theta, but the d theta comes from the fact that we're making very small angles and we're adding up an infinite amount of those. So the angle from the sector from the beginning to the end is infinitely small, and we're adding up an infinite amount of those. So that if the angle ends up being infinitely small, it's acting like a circle because the gap is so tiny. Anyway, the mechanics for it is 1/2 integral from 0 to square root of pi of, and you can even write, instead of writing the equation, you can write r theta squared d theta. I have a lot, we have a lot to get through. So I assume you can plug this in your calculator using math number 9. I had the answers up here somewhere. Here we go. If you I don't know, if you would want to try this, make sure you're getting the right answers. The answer is 3.534, rounded to 3 decimal places. What is the average distance from the origin to the point on the polar curve for 0 to square root of pi? Well, you have to know, first of all, we're finding the average value of a function, and the distance from the origin to the point on the polar curve, well, that's what this is. Because if we have an angle and you plug that angle in and we get a value, that's how far away we are from the center. That's the radius of, not necessarily the circle, but of that point on the graph. So this is 1 over square root of pi minus 0, integral from 0 to square root of pi of r of theta. Not r squared of theta. We're not finding the area. We're finding the average value of r along the curve. And that's what they're asking us to do. If you want to know the answer, if we plug in math number 9, 1.579. There is a line through the origin with positive slope m that divides the region S into 2 regions with equal areas. Write, but do not solve an equation involving one or more integrals whose solution gives the value of m, the value of the slope. Well, for letter C, I've been telling people today that you have area, we already wrote this one, a to b of r squared d theta. Other tools you have are x is equal to r cosine of theta, y is equal to r sine of theta, and the one that we're going to use here that's completely not obvious is the tangent of theta is equal to y over x. And that just comes from just right triangle trigonometry. It's opposite over adjacent. It's y over x. So it says there's a line through the origin with positive slope m that cuts this area in half. So there's some line that goes through the origin that cuts this in half. Well, the slope of that line happens to be the y over the x. So y over x. So here's what we write. So the tangent of theta is equal to y over x, but y over x is the slope of that line. So by the old transitive property, we can say that the tangent of theta gives us the slope. So the theta that we're looking for is inverse tangent of m. Now that would be very difficult to come up with on your own. I get that. But there's problems on the AP tests that are easy. There's some that are kind of right down the middle, kind of medium, not easy, but has some difficulty. And then there's some that are just plain hard to get. And I would imagine getting this right here would be pretty rough. Now we got to use that. Now we're going 1/2 integral from 0 to inverse tangent of m of r of theta squared d theta. We want to know where that's equal to half of the area. So 1/4 from 0 to, what is it, square root of pi of r squared theta, or r theta squared d theta. So where is that angle that would cut the area in half, essentially, is what we're saying. So how far would we go to get half of the area? Yeah. For k greater than 0, let a sub k be the area of the portion of the region S that is also inside the circle k cosine. Find the limit as k approaches infinity of a of k. So we want what's happening as k is getting bigger and bigger and bigger and bigger and shooting off to infinity. What it's saying is, well, I'll tell you what, let me graph this. So I'm going to recreate the graph that we have, roughly. Something like that. If we were to graph k cosine, r equals k cosine, this is a circle. It's a circle off to the right, because cosine is x, so it's off to the right. And it would have a diameter of k. So here could be a possible k. But it's saying as k approaches infinity, so k is getting bigger and bigger and bigger. And I'm not drawing the whole circle, of course, and bigger. And so the question is, how much area of this shape is it eating up? Well, it's getting closer and closer and closer to eating up all of the area just in the first quadrant. Now, it'll never actually get there, because I don't care how big you draw the circle, it's going to, get close to, it's going to hit 0, 0, but it's not quite following the y-axis all the way. It can't. As soon as it leaves 0, 0, it's already away from the y-axis, but extremely close. That's why they're calling it a limit and not the actual value. So what all this boils down to is the limit is 1/2 integral from 0 to not square root of pi, but 0 to pi over 2 of r theta squared d theta. So all you really have to know is that you're just eating up all of the area in the first quadrant. You'd have to know that that has to be pi over 2. So we actually have an answer to what the limit is. The limit is 3.324, and we know that it never actually gets there, but that's what a limit is. What is it approaching? What is it getting closer to? It's getting closer to eating up everything in the first quadrant. I think I over-explained that. What?
I don't know.
See how as k gets bigger, we're getting a bigger and bigger circle. Would you agree?
I would agree.
Okay, so that circle is going to be really huge eventually. Like it's going to be that big, right? So we have the area of this shape that's getting eaten up, that's getting absorbed by the circle just in the first quadrant. So this piece will never be absorbed, right? I don't care how big the circle is, it's going to stay in the first and the fourth quadrant. Well, look how big this circle is, but if we were to zoom in on this, right where this goes here, there's always going to be this little gap. There's always going to be a tiny little bit of area that it doesn't eat up. There'll always be a tiny little piece. But if we assume that it absorbed all of the area of this shape in the first quadrant, if we assumed it absorbed all of it, that's how much all of it would be. So that a limit approaches that value. It approaches all of that area, but never actually gets there. So that circle will always deviate away from the y-axis no matter how big it is, but just slightly. All right. What's the chances of actually seeing this on the test? Slim to none. But it's using the concept of limits, and we're using area again, and they might ask you maybe a similar question in a slightly different way. That's what AP is all about. All right, there's the rubric. One for integral, one for answer, one for integral, one for answer. One equates polar areas. We have the inverse trig function, so they want to see that inverse tangent. And of course, they want to see the equation. One, limits of integration. So they're really looking for that. Did you know that it's looking for the area in the first quadrant? And then, of course, answer with the integral. All right, let's look at this one. The graphs of the polar curves r equals 4 and r equals 3 plus 2 cosine theta are shown in the figure above. The curves intersect at pi over 3 and 5 pi over 3. Now that's great that they gave that to us, but if they didn't, that wouldn't be hopefully too big of a deal. We're going to set these equal to each other. Minus over the 3. So we want to know where cosine is a half. Well, cosine's a half at pi over 3 and 5 pi over 3. So I wanted to show you that just in case you get one where they don't give you the intersection point. We could have gotten that pretty easily, I think. A, let R be the shaded region that is inside the graph of R equals 4. R equals 4 is a circle. It means the radius is 4 all the time. Well, that's the definition of a circle. The radius never changes. And then that dimpled limacon is the 3 plus 2 cosine. So inside the circle is outside the graph. They give you a nice little shaded region to tell you where that is. As shown in the figure above, write an expression involving an integral for the area of R. So we have 1/2 integral from pi over 3 to 5 pi over 3 of the outside area is the circle, 16, or 4 squared, and then minus 3 plus 2 cosine of theta squared d theta. And it just says write an expression. So that means don't evaluate it, just write it. Now what we did when we did this chapter is we would have went from pi over 3 to pi and then doubled it. So we would have gotten rid of that half, make that pi, so that we can plug in, plug in some better, nicer values possibly. So you can use symmetry for these as well. B, find the slope of the line tangent to the graph of that at pi over 2. So let's do this first. Let's go x is r cosine, y is r sine. That's two of the tools that we have in our polar toolbox, so to speak. Well, this is equal to the r is 3 plus 2 cosine. So 3 plus 2 cosine times cosine. And this is 3 plus 2 cosine sine. Now we want the slope of the tangent line. Slope of the tangent line is dy dx. So these get a little lengthy. First, I gotta do y. First times the derivative of the second plus the second times the derivative of the first. And remember that was with, I did the y there, dy. Product rule. Dx is first times the derivative of the second plus the second times the derivative of the first. Yep. But we're going to evaluate this at pi over 2. Evaluate when theta is equal to pi over 2. So cosine of pi over 2. Oh, pi over 2 is going to be nice because we get some zeros. That's going to be 3 plus 0, so 3, times cosine of pi over 2 is 0, plus, I left theta off. Sine of pi over 2 is 1. Sine of pi over 2 is 1. Over cosine of pi over 2 is 0. Sine of pi over 2 is 1, so negative 1. Cosine of pi over 2 is 0. It doesn't matter now, but sine of pi over 2 is, so that'll be negative 2. So we got 0 here, 0 there. Negative 2 over negative 3, 2/3. Now I'll scroll back down, but they're saying that the slope of the dimpled limacon at pi over 2 is 2/3. So right here, they're saying that the slope is 2/3. So we would go up 2 and over 1, 2, 3. That's what they're saying. Seems reasonable with the drawing. I mean, if you got a negative answer for that, then you're like, oh, must have done something wrong, because that wouldn't be a negative slope there. Letter C. A particle moves along the portion of the curve that curve. The particle moves in such a way that the distance between the particle and the origin increases at a rate of 3 units per second. So distance between the particle and the origin. So they're looking at dr dt. They tell us that's 3. Find the rate at which the angle changes with respect to time, d theta dt, find that at the instant when the position of the particles corresponds to pi over 3. So when theta is equal to pi over 3. And the only thing we have to work with is right here. Really, they don't really give us anything else. They give us one value. That's nice. They give us that value. But they want d theta dt. Well, the best we can do is dr d theta. Right? We could do dr d, the derivative of r with respect to theta. But then they want d theta dt. So we could say that, well, dr dt would be equal to dr d theta times d theta dt. So in other words, there could be this r is equal to 3 plus 2 cosine of 4t squared plus 1. So maybe theta is 4t squared plus 1. There's an inside function there that we just don't know what it is. So I have no clue what it is. I don't know. I just know that it's theta. So if I take the derivative of r with respect to theta, but then theta has a t in it, I would just multiply by the derivative of theta with respect to t, and we'd get this right here. So I can get this statement right there. Those thetas would cancel out, and it'd be dr dt. All right, now what do we know? We know dr dt is 3. I need to get the derivative of r with respect to theta, and then I could find out what we're missing. D theta dt. So I got this statement, which is tough enough. And now we have to do a little extra work to actually take the derivative of r with respect to theta. And that's right here. So dr d theta, we're almost there, equals the negative 2 sine of theta. All right, there's the derivative. Evaluated when theta is equal to pi over 3. Negative 2 square root of 3 over 2, so negative square root of 3. Negative square root of 3, there we go. So this ends up being negative square root of 3. So d theta dt is negative 3 over square root of 3. I think the rubric rationalizes it, but that wouldn't be necessary. Ooh, that's a rough one too, I'll tell you what. That'd be tough. But those are related rates. You got to think about related rates and how you can get to what they want. And it's not even that obvious that it's related rates other than maybe right here, 3 units per second. That's a rate. So you're going to have d something over d something when you see those rates. All right, give this one a try. If you're watching this at home, fast forward. Help each other out. You don't have to give values if you don't want to. Just set them up. I assume you guys can do the Math 9, so let's go fast forward and just set these up. I appreciate you getting it out, though. That's awesome. Oh yeah, this one has the W in it. It gets harder to do this without a calculator towards the end. So let's get going on it, I suppose, because we got a few other things to do. Hopefully you thought about the first few at least. All right, I kind of need the answers for this. There we go. All right, so A, find the area of R. And most of these start with that, where you have 1/2 integral from R goes from, what are we going from? 0 to pi over 2, 0 to pi over 2. R is represented by F, so you could probably write F theta squared d theta. We plug that into the calculator. Math number 9, 0.648 would be the decimal value for that. The ray theta equals k, where 0 to pi over 2 divides S into two regions of equal area, right? But do not solve an equation involving one or more integrals whose solution gives a value of k. So theta equals k, or we're splitting up S. All right, S is the area in between the two. So we want 1/2 integral from 0 to k of, is it g and f, I think? So it's g minus f. So g of theta squared minus f of theta squared d theta. So that would be from 0 to k is equal to 1/4 of 0 to pi over 2 of g of theta squared minus f theta squared d theta. So where would we cut that off so that we would have half the area? And so the right side represents all of the area, left side represents half of it. And of course, half of a half is 1/4. For each theta, 0 to pi over 2, let w theta be the distance between the points with f and g. So w of theta is equal to g of theta minus f of theta. And we don't have to worry about absolute value on this because g is always farther than f. So g goes all the way around like this, all the way here. F is always less than it. So the answer will always be positive. So absolute value is not necessary. Write an expression for w theta. Got it. There's the expression. Find WA, the average value of W over the interval. So W of A is equal to, or the average value is 1 over pi over 2 minus 0, integral from 0 to pi over 2 of, is it G minus F? Yeah. G minus F d theta. And I'll tell you what that value is. It is 0.485. 0.485. Now, believe it or not, D pretty much tells you exactly what to do, except it's, I don't know, it's kind of a rough one. Using the information for part C, find the value theta for which W theta equals W of A. Well, we have W of A. So in other words, when does W of theta equal 0.485? When does G of theta minus F of theta equal 0.485? And we would probably use to have more of it. Yeah, 485, they have 446 written down. So don't use the rounded answer within another problem. Don't do that. Don't use the rounded. Use as many decimal places as you can possibly write down. And I know your hand starts to cramp after about 3 or 4 because I've seen your tests, but fight through it. Fight through it and write those 9 decimal places. You can do it, and I believe in you guys, all right? I believe in it. Sarcasm. All right, anyway, I would put this into Y1. I would put this into Y2, find intersection point, and the function hits its average value when theta is equal to, let's see, where is it? 0.517. So it's like saying, you went from Gretna to Elkhorn and you averaged 55 miles per hour. When did you actually drive 55 miles per hour? It was 4 minutes into the trip. That's what we found out. When did your drive equal your average value? At 0.517 minutes. All right, but there's a little bit more to that. Is the function W theta increasing or decreasing at that value? So when you hit this value, are you increasing or decreasing? So you want, let me make sure I do this right. It would be G prime of 0.517 minus F prime of 0.517. And when you plug that into your calculator, use Math 8. If you can use the calculator, try not to do a bunch of derivatives unless you think you have to. Unless you think it's part of the process, take the derivative. Otherwise, use your calculator. Now that ends up being equal to, they don't say. They don't say, don't do that. When you're asked to find a value, find the value, even though technically speaking, we're looking to see if it's positive or negative because we're looking at increasing or decreasing. So don't do what they did. Find that value. Don't risk it. So in the end, it's decreasing. The rubric just doesn't have the value. Don't do that. Don't leave that off. Other things that I grabbed out of multiple choice. We've done Riemann sums. We've done left Riemann sums, and we've done right. We had it on a quiz, and it turns out you guys are pretty good at that. So let's do a trapezoidal rule. On a certain day, the rate at which material is deposited at a recycling center is modeled by the function R, where R of t is measured in tons per hour, and t is the number of hours since the center opened. Using a trapezoidal sum with the 3 subintervals indicated by the data in the table, what is the approximate number of tons of material deposited in the first 9 hours since the center opened? So that's a long-winded way to say we're going to approximate this using 3 trapezoids. So a trapezoid area is 1/2 times the height, base 1 plus base 2. And hopefully, when we did this chapter, that kind of got embedded into your mind. Hopefully you remember that. So we got 1/2. The first height is 0 to 2, so that's 2. And then we have 15 plus 9. Then 2 to 7 is 5, and that's going to be 9 plus 5. And then 7 to 9 is 2. Oh, I need the 1/2 times 5 plus 4. So those cancel. We got 24 plus 14, and half of 14 is 7. That's going to be 35. Those cancel, plus another 9. So 59 plus 9, 68. At time t greater than or equal to 0, a particle moving in the xy plane has a velocity vector given by that. What is the acceleration vector of the particle? Hopefully we can handle this one. Just got to remember the chain rule. So negative 2 sine of 2t and 3e to the 3t. So this is more testing your ability to take a derivative than actually working with vectors. Hopefully that's a slam dunk for you. Which of the following series can be used with the limit comparison test to determine whether the series converges or diverges? I'll tell you on the free response part, there's going to be a lot of ratio tests. There's going to be an occasional geometric series test. You might run into alternating harmonic series and harmonic series on free response, but you probably won't see a lot of like limit comparison or integral test. They leave that for multiple choice most of the time. So anyway, the question is, if we're going to use limit comparison test, which one would we compare this to? Which is it? A, right? It's A. Because we use the highest powers, right? N squared over n to the third, 1 over n. This next one is, we don't see this a lot, but it could be on the test. It's integration by parts. So we have to choose a u and a dv. So we're going to go u is natural log of x. And we pick natural log of x for u because we know what the derivative of natural log of x is. It's 1 over x. Now we have to pick a dv. Well, the only thing we have left is x to the 4th dx. Now typically, especially if we're going to use tabular, we would pick x to the 4th to be the u because we could keep taking derivatives until we get to 0. And that's tabular. So we usually pick u to be the polynomial, but not with natural log of x, because I don't really want to take the antiderivative of natural log of x. I'd much rather take the derivative of that. And not only that, but it works out pretty slick. So there's the antiderivative of x to the 4th. The pattern for integration by parts that you have to know is uv minus integral of v du. And there's a certain amount of topics that I can guarantee are going to be on the test. This is pretty much one of them. I can't imagine a test without at least one integration by parts problem. Maybe that's happened, but it's pretty rare. So now we need u times v minus the integral of v du. So 1/5, well, what's 1 over x times x to the 5th? X to the 4th, right? So one of those are going to cancel out. So that's why we're going to write x to the 4th here. So we have 1/5 x to the 5th, natural log of x minus 1/25 x to the 5th, because the antiderivative of x to the 4th is 1/5 x to the 5th. And we actually have, this is a definite integral, 1 to e. So e to the 5th, 1/5, but natural log of e is 1, so really times 1, minus 1/25 e to the 5th, minus, if I plug 1 in, natural log of 1 is 0, so 0 minus 1/25. Well, now we kind of go answer hunting in this multiple choice problem. Let's do common denominator. We got 5/25 minus 1/25 plus 1/25. So that's going to be 4/25. So 4/25 e to the 5th plus 1 over 25. Well, then, if you look very closely, they're using common denominator. So it's letter B, just with common denominator, 25. So I haven't done that one. I haven't done this one all day. I've completely forgotten to scroll down. So let's do this. The graph of a differentiable function f is shown above on the closed interval -4 to 3. How many values of x in the open interval -4 to 3 satisfy the conclusion of the mean value theorem? So the mean value theorem, the conclusion says there's a c such that the instantaneous velocity will equal the average velocity. But if we think about what derivative is, this is the slope of the tangent line, and this is the slope of the secant line graphically. So if you went f of 3 minus f of -4 over 3 minus -4, you're finding the slope of that secant line. That's what that is. That's old-fashioned slope between these 2 points. Well, this is slope of the tangent line. And if we look at the curve, the slope of the tangent line and the slope of the secant line are equal to each other, let's say here. That'd be the same slope, roughly. I'm a little off. There's probably another one here that has the same slope, and another one here that has the same slope. So 3 times the graph satisfies the conclusion of the mean value theorem. And this is the first time I've done this one today. I kind of ran out of time. What can we do? When x is 0, it should go, 1, 2, 3, 4, as y goes 1, 2, 3, 4. Where's that happening? When x is 0, 1, 2, 3. It could be here, right? It can't be here because when x is 0, it looks like it's just flat the whole time. You see that right there? So I'm ruling out B. Does this have potential? Probably. That one probably has a little potential, maybe. That has a little potential. What about when y is 0? What about on the y-axis? When y is 0, then it'll go 1, 2 would be 4, 3 would be 9. So it's going to increase. So yeah, that looks good. That looks good. That doesn't seem to be going fast enough. 1, 1 should be 2. I don't know. Maybe that's why I didn't do this one. Any other thoughts on this?
Could it not be A?
Why could it not be A?
Because the slope, when y is 0, like to the left of the y-axis is negative. Because y is x squared.
Yeah, y is positive and we have negative values, right? Okay, I like that. Thank you. Then it can't be C for the same reason. Oh, cool. Good job, guys. Awesome. D. You guys are better at that than I am.